Hello, how's everyone doing? Good? I see some nods. Who is going to the party tonight? Most of you. Excellent. I appreciate you being willing to let me stand in your way of Cisco Live and then getting to the parties. I hope everyone has a great time tonight. Welcome to the Cisco U Theater. This is Flowin with Wireshark, hacks and tips to rule the network. That fancy title was given to me by our social media maven, Sonia. So if you like it, you can thank her. I'll be your host. My name is Joe Clarke. I am a distinguished engineer at Cisco in our learning group. I just celebrated my 25th anniversary at Cisco as of June 1st. Thank you very much. 25 years ago, I started in our Technical Assistance Center, supporting our network management products. We didn't have Wireshark back then. We didn't even have the thing that spawned it, Ethereal. We had a briefcase that was a packet sniffer, and we had to bring out this big thing, and we had to wire it up, and it was very inconvenient. So when something like this software, this open source Ethereal came out, and soon or later on developed into Wireshark, this was a cool thing. And vendors like Cisco started seeing that this is a really cool thing. We can stick our proprietary protocols like CDP and EIGRP into this, and we can enable network engineers to do really cool troubleshooting, to control the destiny of their network. And that was fantastic. That finally allowed us to really understand what was going on and be better network engineers. And speaking of network engineers, do we have any network engineers in the house here? Yeah, network engineers, right? A wise network engineer once said, packet capture, it didn't happen. These are words to live by. Back in the day, it was really easy. We had simple protocols. We had Telnet. We had HTTP. The packet capture was something we looked for. We told our junior engineers, give me the packet capture. Now, the network has evolved a little bit since then. We've got more routing protocols. We've got overlays and routing protocols on top of routing protocols. And while everyone wants to try to shove everything in DNS and BGP, there are a lot more protocols out there. And sometimes we get into a habit of saying the network is down, the network's not working. Maybe not us as network engineers, but certainly our users. And how do we prove? How do we dig deep and really say, nope, this is what's happening. I see and I understand the flows that are happening on the network. And so that's what we're going to look at a little today. We've only got 30 minutes, but I thought I'd show you a few things in Wireshark. Maybe many of you are using them, you're familiar with them, but maybe you haven't yet seen some of these features or capabilities. And these are what's going to help you really take charge and understand what's going on in your network. We're going to look at following streams, the decode as feature, a relatively new packet diagram that's great for education, doing remote captures and decoding decrypting all of the things. That sound like a good agenda? Cool. Now, you are at a Cisco event, and this is a Cisco presentation, so I have to have some slides. I personally don't like slides, so while I have some, my intent is to do everything live. So other than maybe some segue slides to remind me where I am and a closing slide, this is really the last one you're going to see. I'm going to jump over to Wireshark. Oh, and I tend, as you can tell, like the sound of my own voice. If there are any questions, just let me know. You can interrupt me. We'll take questions as they come. Ready? All right. So first up, we have following streams. But I guess there is one more slide. Does anyone not have Wireshark, not heard of Wireshark? Crickets. Excellent. Well, if you don't have it, you can certainly get it, and we'll come back to where you can download Wireshark, but it sounds like everyone's got that, so that is fantastic. And here it is. So the first thing we're going to do is look at this idea of following streams. Let me see if I can make this a wee bit bigger. That worked. Sort of, but this is really what I wanted to do. So I'm just going to start a live packet capture. So I'm connected to our wireless network here at the event. So I'm just going to start capturing live on my EN0 interface on my laptop. And already we've got a lot of traffic going on. This is a Mac, so it's doing all sorts of fun stuff that I don't even know behind the scenes. But I'm going to go and explicitly do something. I'm going to reload this web interface. I'll make it a little bit bigger out there. That looks a little bit better. So I've got a GOGS instance. I'm going to revisit this a few times. This is running on one of my cloud VMs somewhere. So I'll reload this. This is HTTPS. Come over and I'll do a little filter. I believe we're doing IPv6 here. Eric will be very happy with me. So let's see if I can find. I'll just do, this is the problem with a live demo. I'll do HTTP. No. There we go. Ah, I think I know why. No? I wanted my HTTP stream here. There we go. So if I go follow this TCP, I can do follow TCP, I can do follow TLS. Depending on the type of traffic I'm looking at, I can do a few things. I'll show you another one in a second, but if I do a follow TCP stream, the idea here, the bytes are the assembled packets, and we'll revisit this in a second. That might not be terribly useful, but one thing that's always useful is being able to pull out all of the packets or all of the frames in the given stream and assemble them without anything interwoven in between them. To look at exactly what's happening in terms of timing between the different packets, to see what's happening in the overall flow of that stream. Now, did anyone ever use Cisco Works as a product? A few Cisco Works users. Like I said, I supported our network management products, including Cisco Works. And back in the day, I would use this to follow a telnet TCP stream and look and see what was happening in terms of interacting with our network devices. This was before SSH became very popular. But Wireshark evolved. It doesn't just do the TCP or the TCP-based protocol streams. I can do DNS, or I can do UDP as well. So in this case, I've got a few UDP, a set of UDP flows here. If I pick, for example, this DNS flow up at the top, and I do follow UDP stream, I lost my screen. There we go. I do follow UDP stream. I get the same thing. The assembled data of the packets may not be terribly useful. However, don't touch anything. Don't breathe. However, bringing out in this case, DNS, the lookup and the response, I can pull out all the cruft in between and get right to where did I see the lookup, and 2 seconds later, I see the response. I get all of that information very clearly in the following of the stream, wherever it happens to be. I've used this with TFTP to watch a file transfer when I'm doing TFTP-based image transfers to my devices or config transfers. Very convenient feature to use to really focus on the stream or the set of packets that I care about. Make sense? That's following. Let's look at decode as. So in this case, I'm going to do another live capture. I'm going to take off that. I'm going to do a filter on UDP. And I've got a script here. Got a script called sendlog. And I'm just going to run this just to give you an example. So let's say you're using syslog, but you're using syslog as an example to a non-standard port. And that's what I'm doing here. I'm doing syslog to port 5514. So I want to look at this. There we go. So I got a packet that came up here, but all this looks like is some IPv6 packet, some UDP packet. Nothing interesting about this. Wireshark doesn't know anything by default about this particular packet. but I know this happens to be syslog. This could also be something like HTTP on a non-standard port, and I want to be able to use the power that Wireshark has, the knowledge it has about the HTTP protocol, to break down the various fields in the packet and allow me to look at that independently. That's where decode as comes in. So if I right-click on this particular packet and say decode as, I get a choice. I can say, okay, it's the UDP port, either the source or the destination port. And in this case, I know that the destination port happens to be my new or my specific well-known port. So I'll choose that. And then I choose what the current protocol I want to be is. It says none by default. I know that this happens to be syslog. I'll select syslog, click OK, and then Wireshark re-renders those packets that match that, in this case, destination port as syslog. So since I sent a syslog message, you can now see that instead of a generic UDP packet, I have got a syslog packet that then I can break down and look at the independent fields there. And the same thing will work with any protocol. If you know that the protocol is working on a non-standard port, you can decode that protocol with that dissector. And when you do something like that, and you come into the preferences, the other thing it does is now saves that port in your preferences. So in the future, you don't have to do that anymore. You've now told Wireshark, this port, treat it like syslog. If you don't like that anymore, if you say, no, that was just a one-time thing, I don't care about that, we can remove that, set it back, and then it goes back to being, in this case, a generic UDP packet. So again, I would use decode as back in the day when Cisco Works, it used port 1741 for HTTP. That's a bizarre port to use. So it would just show up as generic TCP packets, and I could set that to HTTP, and I could dig deep into those using the HTTP dissector. So that's decode as. People using these two already, these are been around for a while, fairly straightforward. Got a few. Some of the other things now, one of the newer things that I really like. So we've seen this bytes view. If you've used Wireshark, if you use Ethereal, you've probably seen this a lot. You're very familiar with looking at these bytes and the hex values, and then some of the data, the ASCII data of it over here. 4.0 added a great new feature from an educational standpoint. Something that I really like, because has anyone ever tried to surf RFCs, IETF RFCs, and look at packet diagrams and RFCs? Yeah, you know what I'm talking. Well, that's great, and those are the canonical source. That's where you need to go. However, there are a lot of RFCs, and there are a lot of protocols. Wireshark knows a lot of protocols and makes that very easy for you. So let's take a look at one of these new features. If we go to Preferences, we go to Layout, we can choose what we want to see in the various panes. And one of the new features is this packet diagram. So if I click this and OK, this pane changes from the bytes display and the hex offsets into that packet diagram that shows you what the fields are. It shows you the bit lengths of the fields. So this is now 48-bit and this is 48-bit. So we can see all of that. And it knows for all of the dissectors that it supports. So in this case, we have generic UDP. So we see that it goes down into the user datagram protocol only. But if I go back to decode as, syslog, now it goes down into the syslog message, showing me the facility information and the message. You also note that it populates the data from this particular packet or frame into those fields and allows me to do things like click on a particular field in the packet diagram, and it jumps right to that in the breakdown of the packet. The other thing that's nice, so we have as network engineers, we're always bringing on new talent. We're always building our teams. And one of the things this lets you do is something like saving this out or copying it as a raster image. So I can copy this diagram, go over here to preview as an example in Mac, and now this becomes an image that I can save, I can print, I can share, I can put up on my wall and say, look, this is what syslog is. And again, I can do this with all types of protocols. So it's a great educational tool, and it saves us a lot of searching through RFCs to figure out how wide a certain field can be, how those things layer on top of each other. It all comes together with this one tool. So something you might not have been aware of and new to the Wireshark 4.0 release. So first three features, some of which you may have been familiar with, maybe you haven't seen this one. The next thing I want to show you is something that we started using when I work at the IETF in the conference networks. We were trying to put together a SPAN, switchport analyzer server, so that we could have everything aggregated and we could look at a packet capture across our network. We can bring ER SPAN traffic to one host and then have Wireshark be able to look at that. And the feature is remote packet capturing. So there's a few things in here. If you click on the interfaces, you may see, especially on a Mac, you've got all of these virtual interfaces and you see your up interfaces at the top. But if you scroll down, you'll note that there are some of these virtual interfaces down here. One of which, Cisco Remote Capture, allows you to do a remote packet capture off a Cisco device that supports it. But in this case, I want to look at the SSH Remote Packet Capture. This allows you to SSH, or Wireshark will behind the scenes SSH into a remote Linux or FreeBSD box or Mac OS box, something with a TCP dump on it, and will capture the packets right there from remote. So we were using it in our conference network to aggregate all of our SPAN traffic and then use Wireshark to connect to that. The thing I'm going to show you today is another interesting use case for this. If you have containerized services running on a host where you have a back-end container network and you want to be able to look and see what might be happening between the containers as they communicate with each other, or if you've got a front-end load balancer, you want to see what happens after the handoff. So once the traffic hits the load balancer, you can see that by sniffing maybe from your client, but what happens from the load balancer to the containerized application? Using a remote packet capture, we can connect to the host that's running the application, and then we can do the packet capture on that internal interface. So I'll remind you about this. This is my kind of poor man's GitHub running in my running on one of my cloud VMs. This is called GOGS. This is a Go-based application. It does GitHub-y-like things. It serves everything out of HTTP. I have Apache in front of this. So Apache front-ends this and allows me to provide an SSL or TLS certificate. And then the back end, this thing runs in a container on the back end on a specific network port. So I'm going to, if I Wireshark on this on the front end, I'll just see my HTTPS to this server. Not terribly useful, but what happens after the HTTPS handoff? What happens when Apache starts talking directly to GOGS? That's what remote packet capture will let us see. So I'll configure my remote packet capture. I tell it the server I'm running on, that's my server, the port. Authentication. Now, there's a few things you can do for authentication here. You can put in a password if you want. I don't recommend that. I recommend you use SSH public-private keys, a little bit safer there. If you've got a passphrase for your key, you can put it in there. And then on the capture side of things, you have a few options. You specify the interface on the remote host that you want to capture on. In this case, I'm going to do the way it works. I'm going to use my loopback 0 interface. You specify the command. Typically, it'll be TCP dump. Most Linux, FreeBSD, Mac OS machines will have TCP dump. But you can also use the dump cap command that comes with Wireshark, or a specified command of your choice that will output libpcap data. But TCP dump is a good choice. And then because most of these operations, like sniffing on an interface, require root privileges, I'm going to use sudo on the remote host. Bit of a caveat here. Sudo, in order to do this right, you need to be in a group or allow for TCP dump in sudo without a password. So your profile, your user, whoever you're logging into the host with, will just allow you to run sudo TCP dump without the password. The cool thing about this feature is it automatically includes a packet capture filter that will prevent it from capturing itself. That way you don't just have gobs of garbage in your packet capture. And then I'm not going to limit any of the packet capture. I'm just going to say capture until I tell you to stop. So we'll go ahead and save that. That seems reasonable. I'll start. Continue without saving. I don't want that filter anymore. So it's already starting to capture some noise that's happening on my loopback interface. But I'll go ahead and reload this interface. So this is talking to the Apache front end, and then Apache is handing that off to GOGS on the back end. Back here, I'll stop this, and you can see that it's already gathering data, or it's already collecting the backend HTTP request. So if I do another follow here, follow TCP stream, you can see that now I'm seeing the handoff, the HTTP. After the TLS, after Apache's done, it's doing HTTP back to GOGS, and I can then troubleshoot based on those packets. So if I suspect, for whatever reason, that my monitor keeps going off, if I suspect that the front end, the load balancer, the Nginx, the Apache might be doing something that's corrupting the packets, like if my GOGS isn't working and I'm trying to troubleshoot that interaction, this is one great use for remote packet capture. Another one is that span use case. If you wanted to do a remote span from a Cisco device, like a Cisco switch, to a central host, like a Linux host, then you can use this as a means to always gather that data, to connect to the data port that you've got configured on that Linux host as an example, and capture that traffic. Have it all in one place and do it all from your desktop without doing a lot of extra setup, without doing a lot of manual TCP dump and streaming that to Wireshark. Wireshark can do all of that for you with this remote SSH capture. Make sense? The last thing I want to go over, question.
So Wireshark can remote TCP dump only on the Linux hosts.
The question is, you can do remote TCP dump only on the Linux host.
We're talking about Cisco devices, then we'll have to use span.
If you're talking Cisco devices, then you have to use span. Well, it's Linux-like host, first of all. So this particular host happens to be FreeBSD. Any FreeBSD fans? All right, good. Or Mac OS. But you're right. On the Cisco side, there is a different remote packet capture utility called Cisco Remote Packet Capture. So Cisco devices these days do have a built-in packet capture mechanism that can spit out libpcap data. I didn't have one on my Edge, and I wanted to show you guys live demo, so I chose the SSH capture. But you can use this to a Cisco device if you wanted to, without having to do a true span. The reason we like the SSH dump for our remote span is in the IETF, we have two Cisco 9500s in a VSS, or in a pair, and a stacked pair. And we also have 9300s out at the edge. We like to do the ER span back to this one host, the host that we set up. We call it Sniffer. It's a VM, and then we can use the remote packet capture then. So we have a data plane interface on a specific VLAN for the R span. We can then use this to capture that traffic. It was very convenient. So the last thing I would like to show you is something that I think is fantastic in this world of encryption, and everything must be encrypted. The IETF, in fact, had a mandate that any new protocols that you had out there must have encryption on them. You cannot come up with a new clear text protocol. So we have a lot of, just about everything has to be encrypted. And almost everything you see today out on the internet, certainly anything you're doing in your browser, is going to be HTTPS. You'd be really leery if you went to a site and for some reason it said not secure. Back in the day, that was no big deal. Most things were HTTP. Maybe we were a little cautious if we were ever going to put our credit card into something, we'd look for that lock icon. These days, especially with like Let's Encrypt and free certificates, everything is generally encrypted. But how do we troubleshoot that? How do we get inside of that packet and see what this application data might be? Wireshark has a means for that. It's not doing anything in the middle type of attacking. What it is doing is allowing you to save off your keys, your key data, your session encryption data, and then it can look at that to be able to decrypt the streams that are terminating on the device that you're currently on. So in this case, if I wanted to troubleshoot and look at the decrypted data of my TLS connection to my GOGS application, what I can do, and most SSL TLS packages support this, is I set this environment variable, the SSL key log file. This is more or less standard. This will work on Windows, Linux, Mac OS. This is baked into the underlying SSL or TLS package. That's OpenSSL, Libra SSL. I think there's a few others that do support this particular, those Libra and OpenSSL, NSS, the one that Firefox uses, those all support this same variable. So this environment variable, SSL keylog file, set it to a path to a file. And this will be a text file that has all the pre-master key and master key data that's needed to decrypt those sessions. First, you set that environment variable, and then you'll have to restart your browser in that environment so that the browser sees this variable. Other commands like curl, wget, they also support this because it's baked in not to the individual commands or processes, but it's baked into the SSL or TLS providing library. So we set this. I've already restarted my browser, but I just haven't loaded it into Wireshark. So once you do that, then you would go in your browser, reload your whatever, your application, your site, what you want to see, and then you'll notice that this SSL keylog file now has this data in it that will specify what's needed to decrypt from that session, what's needed to decrypt that data. At that point, you come back to Wireshark, preferences, protocols, TLS, and you specify the path. So the file, the reason why you had to reload first is to first create that file. Then you specify the path to the pre-master secret log. I'll do that. Get it there, click OK. And then you can see it decrypts all of that session data automatically. You may have to reload again to get the current session to decrypt. But now when I click on it, I no longer just have the random application data. Now I can click on it and do a follow HTTP stream. And now instead of all of those random garbage bytes from encrypted TLS data, I have the actual clear text, plain text HTTP. Images, JavaScript, CSS. And this works for any protocol using those underlying TLS libraries. Doesn't have to just be HTTP. Once you set those libraries up and you're able to invoke those application traffic, able to invoke those application flows again, you'll start to see that file fill up with those additional session details, and Wireshark can make use of that for any TLS flows. So now I have an ability to get through even the decryption as long as it's terminating on my particular endpoint that I'm running Wireshark. Excellent for troubleshooting. Make sense? Good. So those are the things that I wanted to show you. Hopefully you got something interesting from Wireshark, something you can take back and make use of in your network troubleshooting. Last thing I'd like to do to close it out, turn it back on you. Sounds like everyone here has Wireshark, so that's fantastic. I would encourage you to explore the options. We just scratched the surface here in the Cisco U theater for a little bit. We just scratched the surface of what Wireshark can do. If you don't have Wireshark, here's the QR code. There were slides backing this, but fortunately for the most part, except for the monitor going off a few times, the demos worked. So take this back, keep flowing, keep understanding your network, and especially as network engineers, never stop learning. Thank you very much. But wait, there's more. I'm told that under one of your chairs, for those of you sitting, those of you not sitting, obviously you don't have a chair,